So as I said, I'm Daniel. I am an staff iOS engineer at Aminas, which is a little bit to say because I've spent most of my years contracting. This isn't about the work that we're doing at the moment, but maybe it will be in the future. In the last kind of year and a half, I've been working with design systems at Deliveroo and Laps, which is a small startup taking photos for social media. And you post and share them. I honestly didn't understand the product. I did the design system part. I came in, did a small contract, and created them a design system, which is mostly what I'm going to talk about this morning. So I guess maybe what everyone's come here for is to talk about the design system part. I'm just going to lay it out now. I've lured you here. This slide is pretty much the only slide that's going to talk about actual design system stuff, as probably described by the community of design system people. What is a design system? It depends who you ask. Like at Deliveroo, we saw it as the process, the documentation, some common resources, which were like figma files that were shared across all the designers that they could use as templates, and functional libraries that would have shared common stuff across Android, iOS, the web, and all of that. And this last bit is probably the most interesting part for us, because we're building that stuff, and the rest of it is stuff that's normally handled by the team, other members of the team, but obviously they'll interact with us quite a lot, some more than others. These functional libraries are interesting because a big goal of design systems is to have this common language, and what I found with SwiftUI is that the common language that design systems tend to want in terms of a figma file is laid out in a certain way using components in that work differently to how SwiftUI kind of wants you to work. So the rest of this talk is basically, we're going to look at ways in which SwiftUI should implement these functional libraries, how you should do that in SwiftUI, and maybe how different that is from other techniques from Figma, for instance, and maybe where we can find that shared vocabulary to describe shared components. So it's always about buttons, design systems, I don't know why. Obviously they've got everything going on for them, right? They've got text and colors and press states and I don't know, like it's everything, it's interactive. And then you put loads of them everywhere because you want your apps to be interactive. So you're going to be pressing a lot of them. So maybe you want to make this button here. In SwiftUI, you might come along and say, write a primary button view, which is really easy to do. We can wrap the button in the body, get the font we want, give it some padding. This, by the way, is massive, 60, because it has to fit on the slides, right? If it was tiny, you wouldn't be able to see that previous button. And then we've got a background on it and foreground color and job done. And we've passed through the action to the button so that when the button is shown, the user can interact with it. Obviously, there's a bunch missing here, right? There's no accessibility options, there's no tab state, for one thing. But it's given us this kind of primary button that we can call primary button from wherever we want. Give it the string that we want to display and the action we want to handle. And primary button's probably what it's called in Figma, so that's great. And we can see that if we make one here on the left, it looks exactly like the button we wanted. Surprisingly, that might have been the code that I used to write the previous button. Because someone is going to come along and say, but we need to support images in Figma. That was just simple because we can just chuck an image in there. And in SwiftUI, you'd be like, okay, cool, I'm going to make another button, make this primary image button, and it's going to have an image, not text. And we can put the image inside the label of the button. We're still going to call the action that we're given, and we'll provide all the same styling at the bottom. Great, ship it. And that works really nicely. But there are some problems here, right? Primarily, you've now got two places where this style exists. It's not general for any type of content. If someone comes to you and says, we want to stick a video in a button, you can't do it. I mean, that might be a good thing. And these buttons aren't really easily discoverable in the system. If you type the word button into Xcode, it's going to give you SwiftUI's button first, and then somewhere down, it's going to give you primary button, primary image button, primary video button, primary, I don't know, whatever you want. But, so that doesn't really scale. And design systems are about scaling. I keep being told. The great thing is that SwiftUI comes with something called button style. And this is where SwiftUI wants you to go down this route of styling buttons using button styles, because they compose nicely and you can apply it to the standard button that's already provided in SwiftUI. And to do that, you implement this protocol, which has an associated type, which is just a way of saying it's going to return some view. And it gives you a configuration, which is this button style configuration. And inside of that, it will give you the label, and the label is the content of the button. And you won't be able to go inside it and basically mess around with it, because they don't want us doing that, the evil Apple people. So we can't do any of the old tricks we used to do in UIKit, but we can style our button, which is kind of what we're here for. We take most of the similar code from before, except we don't have to deal with the action. We just grab the label from it. Like I said, we didn't handle any tap state here, so in this code, we also get the tap state from the configuration as well, and style it appropriately, so we've got different styles when it's tapped. The rest of this talk, you can assume that we should add that tap stuff, but I've never done it, because otherwise these slides would become really huge. And that's not really the point of this talk. So instead of having a primary button, we can just use a regular old button, provide it the content we want, and style it with the primary button style. And then you kind of ask me, well, you keep saying about this discoverability thing. Sometime in Swift, and I tried to do this up this morning, I couldn't find it. I think it was the second year SwiftUI was out. They added the ability in Swift to extend protocols where self is something that implements the protocol, and you can define a static variable on it, and that allows you just to basically do a dot and say, hey, I want the primary button style. So as soon as you press the dot, it will give you literally all of the button styles that you've got access to, and you can style the button however you want. We also get image handling, because buttons can take images. In fact, they can take all kinds of content. They get this text and image initializer is on button as well. If we just style that with our primary button style, it's all great. Just works. Designers love to design things. So this designer here wants to add, let's say, a stupid amount of space to the middle of that button. I'm not judging. It's officially stupid. But just say they want to do it. Now, we could go through and say add a text image button with some spacing, and again, it's 100 because it has to be on the slide. Putting the image and text in a H stack. Hopefully, we're starting to see that might not be the way to do things. This would be the result of that. Text image button, and our primary button style still works because it's a button inside of that, and styles kind of go up or down the environment, depending on which way you're looking. So this button style will go down into the text image button and then go down into the button inside of that. So that would all work really nicely. On a previous slide, we had this initializer for what SwiftUI creates as this text and image. What is this? It turns out this is just an extension on button, providing a specialized initializer where the button's label is a SwiftUI label with a text and an image. And a label is defined as a struct which has a title and an icon, and they can be any view. They don't have to be image and text. It's just that most of the initializers expect them to be image and text, and to be honest, their names kind of suggest that they should be. And we can create these. This is a SwiftUI view. You can use it all over, and probably implicitly use it in a lot of places too. When we create one of these, we just get a text next to an image. Kind of not surprising given the button we just saw on a previous slide. And then there's this short initializer which takes the title and the system image, and that will give us a label with text and image as the generic parameters. So this is a common way of initializing a label, and unsurprisingly, maybe there is a label style that you can use to style these labels, and it's very similar to button style. There's configuration, and the configuration has both the title and the icon properties. And to implement one, you implement the make body. You grab the icon and the title from the configuration, and we can just put that in an H stack with this stupid amount of spacing, crucially. So we've made probably the world's worst label style, because they're so far, like, I don't know what this business is thinking, but they love it. The image is far away from the text, and it's all Ruby, right? The really cool thing is that in our primary button style that we wrote, we can use that label style so that any label that appears in a button is styled with the primary button label style, which means that we can do this with a normal button using our original primary button style, and we get it stylized correctly with the space between the icon and the text, even if we think it's stupid. Designers are funny, and this is all genuine, right? Like, these are all genuine examples. Like, I haven't made this up. It was one of the world's easiest talks to write because I'm like, well, I don't have to come up with weird side scenarios. Can we have 3 lines of text in our button? Is the request. Sure? Yeah, all right. The hardest thing about the entirety of this slide, you must understand, is that title and subtitle are kind of a given. The third thing, what do you call that? We ended up calling it caption, but there's no subtitle. It literally was called that for a week. Because I was like, that's the only thing that makes sense here. Probably means that it shouldn't have 3 of them. If someone's got a better word, then I'd love to know, but I've stopped contracting for the company. So, I mean, it'd just be triviality at this point. So as stuff's getting more complex, the code is getting smaller. So hopefully you're kind of tuning yourself into this small code. And I would apologize for the amount of code on the text on the screen, but I would genuinely give them the live code this, so I'm really glad I didn't. We could make this vertical text button, right? As the title, subtitle, caption, action. Can we all just assume that we know that we don't do this now? Right? This is not the way to do it. Like, yes, great, it's going to give us the thing we want, but hey, we've just invented another button. How do we do this, right? Like, and crucially, what if our button styles want to stylize each different thing? So if we had a primary button style, maybe it wants to show all the text, but a secondary style actually doesn't want to show the caption. Or maybe it wants to make the title massive and have 100 points between it and the subtitle because the designer came up with that idea. I would suggest creating what I would call a semantic container, which is what I would refer to the label as. The label semantically says, I've got an icon, I've got a title, and that's all I know about the world. And the style actually denotes where stuff goes on screen. So we're going to try and mimic that as this container. So this is a view which is generic over a title, subtitle, and caption view. It's got a nice view builder initializer, and all it does in body is put them in a V stack. Don't worry about this too much, because most of it's going to get replaced in here. We also want to make a detail style because we want the same kind of behavior as we have with label style, because that's really handy. And we know that what label style looks like. It's got this configuration thing, and it allows you to return any view. Has a make body function, so let's just start with that, right? Importantly, it's a dynamic property, and that helps with using the environment in a style object or value. This configuration thing, what we really want is to be able to provide each of these views out to the caller. And as far as I can tell, what label style does is just wrap each of the views that are given to the configuration in any view and some form of opaque type that comes out. So we've done that here with the title, subtitle, and caption view, such that when you implement the protocol, you can't actually get access to the underlying view. That's helpful to make sure that styles don't change the content, but it's also realistically the only way that the whole thing builds in Swift because of how generics would filter down, especially through protocols. We know that we're going to be setting the style in the environment, so we make a nice function to be able to set the detail style such that anything in the tree underneath us will be styled with the same detail style. And we'll propagate that through the environment, and we'll make all of that private because no one needs to worry about that too much. And we'll provide a default style. So a fairly decent one would be this VStack, using some horrendously huge fonts so that we can actually see it on the slides, such that they just line up one after the other, knowing full well that if someone wants to style it themselves, they can implement the detail style and do whatever they want. I mean, technically you could put them in a H stack, you could use a Z stack if you want. I'm sure some designer would love that. This isn't me just really, going against designers here. They're great people. Yeah. This is a trick that I saw in a blog post that I tried to find a reference for, but I can't. So if someone knows the reference, I would love to reference it. Who is it?
Moving parts.
Moving parts. Thank you. I don't know who shouted that out. You did. Thank you. So it turns out that, and this is a bit really into the weeds about some of the generic stuff that happens here, and maybe the dynamic stuff of the environment. So we want to be able to use environment in a style type, and that's really useful. It's useful in buttons because we want to see whether that button's enabled, and you would want to provide a button state, a button style for when that button is disabled, and that comes down through as an environment property. That's one example of what you would want to use it for, but you might want to just propagate anything into the environment to cause styling changes. And that propagation is needed through, is done through the dynamic property on that protocol from a couple slides ago, which means that go back 1 second. When we've defined this environment key, we've defined it as any detail style here. You could write your own opaque wrapper around that, just any detail style, because it's a function that's adding style to this view, in which case you'll end up with some more any views going around the place. But that won't get the propagation of the environment. If you do this, when it comes to actually using a style, you don't actually have the actual thing, you have the protocol boxed version. So the system doesn't know what type of style it is to call. So the trick with this is that we call resolve on this in a detail style, and it doesn't know what it is until inside the function, when inside the function it does know its own type. So it can resolve itself, and the Swift, something in the system, we'll be able to see, okay, yeah, this is a plain detail style. I'm going to call the plain detail style implementation of make body here. The blog post really explains it better, so I recommend looking at that if you're interested in the details of that. So now we've got all of the building blocks in place to create a detail style. We can propagate it through the environment, which means that in the detail type that we wrote, we can add an environment property at the top for the detail style, and at the bottom, instead of putting it in a V stack, we can create a detail style configuration using our 3 views. Remember, they're going to get wrapped into the opaque types inside the detail style configuration. And then we're going to call resolve on style, which is part of the resolver, passing the configuration in, and that's where the style becomes fully realized as to what it actually is. And this will cause the style to be used for the layout of the detail. So with the default style, that plain detail style that we had earlier, if we use the code on the left, the right-hand side comes out. So we've got a nice bold title, a subtitle, and caption. We can also implement our own one of these for the primary button that we're making, if we can remember that long ago. We'll make some modifications that we want because the designer wants the alignment to be leading, and there's some size differences, weight differences going on here. And we can add that to the bottom of our list. So the really neat thing about this is that you don't need to know what the button contains. Right? If there's a label, it will apply the label style, this label style. If there's a detail style, it will apply that. It applies it no matter what. It's just that if the content does have a label, it will take that label style. If it does have a detail, it will take that detail style. So the button with our detail style, with the primary button style, will take on our primary button style. We can also do some nice things like create a nice button initializer so that the users of the design system don't need to remember, oh yeah, for this particular case, I need to use a detail inside of a button. You can just provide, hey, provide me a title, subtitle, and caption, and I'll make the right kind of button for you. And it looks a lot neater. It's a lot neater, and you get nice autocomplete for it. And the user doesn't have to worry, the user being like your end developer of the feature, doesn't have to worry too much about what type this button actually is. It will just be correctly styled and correctly laid out. And because of the way styles interact, you're always setting a label style, you're always setting a detail style. If you put a detail in a label, in the primary button style, they will nest, and you will get the horrendous 100-point spacing here. You will get the left leading aligned labels here. We can also make a convenience initializer for that, much the same way. We're just kind of making the struct inside of the initializer essentially. And we can make as many of these as we want. And they're all on button. So all the user has to do is type button, dot init, or open brace, and they'll get all possibilities that they've currently got in the system. And if they want to style it, they can just put dot button style, dot, and it will show them all the styles that apply to buttons. And that's what the nested button convenience looks like. What if we don't want a caption? Now, I said previously, like some button styles might not want to show captions, but in this case, it's a user-defined thing. It's like, well, in this button, actually, I don't want a caption, so I'm not going to provide one. We can actually provide empty view, and that will just mean that everything's ignored. This is really powerful when making design systems because it stops you from having to implement so many different variants because, hey, you can just omit it with an empty view. And again, you can make a specialized initializer which just doesn't have the caption inside of it, and then use empty view as your generic parameter in the detail. And that works as you might expect. And this is kind of most of, I think there's probably some more buttons that we've made in this talk. So we've got kind of a basic one at the top, one that's a label, so the image on the left, so, the detail one in the third one, and they're all styled exactly the same. So this is in a V-stack, and we just got one button style that we've applied to all the buttons in that, and it goes down the environment. So it's super cool. That's literally the only API we've added for all of these styles. So in summary, when doing these design system things, I'd say prefer using custom styles over views. They're really powerful, they nest, and they're way more discoverable. Nest the styles, because that's also just, the less code you write, the less code everyone else has to learn. And these semantic containers are really useful for when you want to use them in different contexts. So we could provide, say, a table view with a label, or we could provide a table view with a detail, or a combination of both, and use both of those to lay out the table view row. And basically just reuse that and reuse the styling for that across different things. So it's really powerful to compose that stuff in that way. And that is something I don't think doesn't really exist, at least in the web, where you can compose it in that way. It definitely doesn't exist in Figma when you get in designs. So that's just where SwiftUI is going to kind of butt up against design system people coming from design. And that's most of what I have to say.